Thank you, Paul, for introducing me, and thank you, everybody, for attending this webinar. And so today I'll be presenting over the impacts of passive fishing gear on alligator snapping turtle populations in East Texas. And so this is part of my master's research. I just graduated from Stephen F. Austin State University about a week or two ago, so I'm excited to talk about this. And so for the purpose of this talk, I divided it into two parts here. Let me see if I can get it going. There we go. All right, so I divided it into two parts. The first part dealing with the persistence of passive fishing gear in East Texas streams. And then the second part pertains to the impacts that these devices have on alligator snapping turtles. And so with that, let's get started here. And so worldwide, aquatic fauna faces a multitude of anthropogenic threats, especially in freshwater systems. So pollution, overharvesting, flow modifications, and water extraction has been attributed to population declines in about a quarter of freshwater species. Now, bycatch also poses a significant threat to freshwater and marine biodiversity, and even abandoned fishing devices can effectively fish without human involvement, which is known as ghost fishing. And so while most studies have focused on bycatch and ghost fishing in marine systems, little is known about the persistence of fishing gear in freshwater environments, especially in these small stream systems that are known to provide an important habitat for many species of conservation concern. And so while we might not have these giant shrimp trawlers boating around our rivers and lakes in East Texas, we do have passive fishing gear. And so passive fishing gear includes trotlines, limblines, and juglines. There's many different names for these types of devices, but basically these are passive fishing devices that anglers deploy out in rivers and lakes. Usually they're left out overnight or for a handful of days. However, they're frequently abandoned and they can accumulate in these aquatic ecosystems. And while they're typically intended to catch catfish, they've been known to catch a variety of aquatic organisms, from non-game fish such as pallid sturgeon to freshwater turtles to even diving ducks. And even these abandoned passive fishing gear can continue to hook or entangle aquatic organisms long after they're deployed. In fact, during a recent study on a Texas reservoir, researchers found that over 68% of organisms caught during the study were caught by baitless trotlines. However, the impacts that these devices have on aquatic organisms likely depends on the type of gear used, since limblines and juglines typically consist of 1 to 5 hooks, while trotlines can legally have up to 50 hooks in the state of Texas. It also depends on the life history traits of the species that's caught as well, and these devices can be particularly harmful to species with low fecundity or delayed sexual maturity, like many freshwater turtle species. And so due to those traits that I mentioned, just a small increase in adult mortality can lead to population declines in many species of freshwater turtles. And so, in fact, freshwater turtles are among the most imperiled groups of organisms in the world, with over 50% of species classified as threatened. And now, recreational fishing poses a major threat to freshwater turtles and has contributed to the extirpation of various turtle species. And passive fishing gear has also been identified as a pervasive threat to the alligator snapping turtle, which is a state-protected species here in Texas and a candidate for federal listing under the Endangered Species Act. However, when it comes to quantifying and monitoring these types of devices, it's pretty difficult. So passive fishing anglers are rarely encountered during creel surveys, and as a result, only a couple of studies have attempted to quantify passive fishing gear abundance. And furthermore, the detectability of passive fishing gear under various environmental conditions has yet to be examined. And so the goal of this study was to quantify the persistence of passive fishing gear in our East Texas streams. And so our first objective was to quantify the spatial and temporal variation in density and detectability of passive fishing gear. And then the second objective was to examine the type and legality of these devices. And so we surveyed 2 study sites in East Texas. Our first site is a section of the Angelina River, locally called Shawnee. So for the purpose of this talk, I'll just be referring to the site as Shawnee. And so Shawnee borders Nacogdoches and Angelina counties. And then our second site is a section of the Atoyac River located just upstream of Sam Rayburn Reservoir, which also borders Nacogdoches and San Augustine counties. So both sites are fairly small streams located within the Piney Woods ecoregion in the Neches River Basin. And so before we started our study, we conducted pilot surveys at our sites from May through June of 2023 to look at whether passive fishing gear was even present at these sites, how accessible these sites were for the anglers there, such as the number of boat ramps, and how many people were fishing these streams. And so we surveyed for passive fishing gear from August of 2023 through August of 2024. And we conducted monthly surveys using a systematic sampling design with a random starting point. So this figure here is a section of the Atoyac River. This star represents a random starting point. And then we conducted 100-meter parallel transects spaced about 250 meters apart. Now in total, we conducted 9 surveys at the Atoyac and 11 surveys at Shawnee. Now, once a passive fishing device was found, we recorded the GPS coordinates of the device and gave it a unique ID, the type of device, so whether it was a trot line, limb line, or jug line, the condition of the device, so whether it appeared active or abandoned, and then lastly, the legality of the device, which was inferred from the presence or absence of a legally required gear tag. Now, the condition of passive fishing gear was determined by the appearance of the line. And so specifically, we were looking at whether the line was frayed, tangled, or knotted, whether it had algal growth, or if the line was positioned out of water. So for example here, this is an abandoned trot line found at the Atoyac. And so once I zoomed in here, you can kind of see that small line, which is the dropper line hanging from the main line. There's some algal growth on that dropper line, and the trot line's positioned out of the water. So that's how we were able to determine this. Now we then compared the differences in the proportion of each gear type and the condition of gear using chi-square tests. So this figure here shows the percentage of each gear type found at our study sites. And so on the x-axis is the sites and the y-axis is the percentage of gear. So overall, we found significantly more limb lines than trot lines or jug lines, as you can see here in the brown. And then this next figure shows the condition of gear that we found at our sites. So again, on the x-axis is the sites and the y-axis is the percentage of gear. So overall, the vast majority of passive fishing gear found during the study was abandoned, as you can see here in the red at both sites. Furthermore, all passive fishing gear found during this study lacked a legally required gear tag. Therefore, they were all illegally deployed. Now, we then estimated the density of passive fishing gear at the Atoyac and Shawnee for each season using a variation of the Horvitz-Thompson estimator, which basically takes into account the interaction between the number of primary sampling units and the population means. And so these densities were estimated seasonally for the fall of 2023, winter of 2023 through 2024, and summer of 2024 seasons. All right, and so this figure represents the seasonal density estimates of passive fishing gear. And so on the x-axis are the seasons, and the y-axis is the density of gear per kilometer. And so we estimated the highest densities of passive fishing gear during the fall of 2023 at about 10 devices per kilometer of stream at the Atoyac and 18.7 at Shawnee. Now, there was a decline in the winter from 18.7 to 14.7 devices per kilometer at Shawnee. However, our density estimates remain steady at the Atoyac at 10 devices per kilometer. And then lastly, during the summer, we estimated the lowest densities of passive fishing gear at about 1 device per kilometer at both sites. Now, to account for imperfect detection, we also looked at how these different variables affected detectability and angler effort. And so we used a Bayesian logistic regression framework to estimate the probability that a previously detected device would remain observable after subsequent surveys. And so the covariates used for these models included gauge height, river discharge, which is the volume of water flowing down these streams, precipitation, and time, which was the number of days since the gear was first detected. You can kind of think of this as the age of the gear. And then all these covariates are standardized before running our models. So these last series of figures shows the predicted probabilities of detecting passive fishing gear from our best fitting model. So on the x-axis are our standardized environmental variables, and then on the y-axis is the probability of detecting passive fishing gear. And so starting out with figure A there, the probability of detecting passive fishing gear declined with increasing standardized gauge height. It also declined with increasing river discharge, and also increased with increasing time. However, there was a slight increase in detection probability with increasing precipitation. Now, we found a significant interaction between standardized gauge height and standardized time. And so on the x-axis of this figure is gauge height, and on the y-axis is time, and that darker shaded region represents higher detection probabilities. And so as gauge height increased, and so did time, the detection probability of passive fishing gear declined drastically. So passive fishing angling typically varies seasonally, with most effort occurring in the spring and summer, followed by a decline as water temperatures cool. However, the seasonal differences in passive fishing gear density observed during this study were largely driven by these extreme weather events that affected both angler effort and gear detectability. And so water levels were fairly low at the start of the study, as you can see here, due to extreme drought in Nacogdoches County. However, over time, water levels rose, and then we experienced major flooding across all of our sites due to Tropical Storm Beryl that hit in July of 2024, which reduced accessibility for anglers and likely deterred new gear from being deployed. And since most passive fishing gear is set right at the water's edge, this increase in water levels as a result of the flooding reduced the detectability of passive fishing gear. And also the high flows from these floods may have removed the gear from the structures it was attached to, or just removed those structures entirely, such as tree branches or tree roots. Anecdotally, after this flood, there was an abundance of fallen trees. And so we also found a slight increase in detection with increasing rainfall. Now, this may be due to also angler behavior as well. And so catfish anglers are known to target catfish after rainfall events, and the rainfall may have also improved site accessibility when the water levels were fairly low at the start of the study. Now, it's also important to note that the vast majority of passive fishing gear found during the study was abandoned, and it was all illegally deployed. And so it's possible that this gear can persist longer in these small remote stream systems, since they're less accessible and often overlooked by law enforcement. And the prevalence of abandoned gear and the lack of gear tags appears to be a common occurrence in many U.S. water bodies, which just highlights the challenges of our current fishing regulations at curbing violations. And so without better systems for identifying users and ensuring compliance, such as through registration, permitting, or enhanced penalties, the current regulatory framework is unlikely to prevent the ongoing accumulation of abandoned gear in freshwater systems. Now, to reduce the impacts that these devices have on aquatic vertebrates, organized river cleanups may be necessary to remove abandoned gear. And so during periods of low gauge height or river discharge, we could further optimize these cleanup activities when the detectability of passive fishing gear is improved. And so this regulatory gap poses a continued threat to species of conservation concern, such as the alligator snapping turtle. So moving on to part 2 of this talk pertaining to about the impacts that these devices have on alligator snapping turtles. So the alligator snapping turtle is the largest species of freshwater turtle in North America, which ranges from the Florida Panhandle westward into East Texas. However, despite its large range, alligator snapping turtle populations have been in decline due to its life history traits and the multiple anthropogenic stressors that it faces. And so while adults are long-lived, hatchlings and immature individuals are characterized with low survivorship, where the average age to reach sexual maturity can range anywhere from 11 to 21 years. And so due to these life history traits, it makes it difficult for alligator snapping turtle populations to recover from environmental or anthropogenic changes. Now, due to its large size, it was also commercially and recreationally harvested historically throughout its range, which contributed to the population declines and range contraction. Now, this is a state protected species here in Texas that can be found throughout much of East Texas's slow-moving water bodies. And so a previous study conducted by Rosenbaum et al. 2023 estimated a range-wide density of about 8 individuals per kilometer of stream across East Texas, with the core of its range residing in the Sabine, Neches, and Trinity watersheds. Now, passive fishing gear has been identified as a prominent threat to the species, not just in Texas, but throughout its entire range. So numerous studies on alligator snapping turtles have documented mortality events caused by these devices, and previous studies have reported lower catch per unit effort at sites with trot lines than at sites without. Furthermore, researchers have found that alligator snapping turtles are highly susceptible to population declines from fishhook ingestion. So this figure here is from Steen and Robinson, 2017, which shows the population trajectories of alligator snapping turtles over a 30-year time frame. And so at sites without fishhooks, populations were expected to increase from 500 to about 700 individuals, whereas at sites with fishhooks, populations were expected to decrease from 500 to about 1 to 200 individuals, which just highlights the impacts that recreational fishing has on the species. And with the recently proposed listing of alligator snapping turtles as federally threatened under the Endangered Species Act, it's imperative we quantify the scale of this threat and the demographic impacts these devices have on the species. However, there's also a lot of uncertainty around alligator snapping turtle populations across its range. And accurate estimates of abundance and other population parameters are fairly rare in the literature. Now, the most common method used to survey for alligator snapping turtles are hoop nets, as you can see here in these two images, for example. But there's many issues that arise when using these devices. And so the distance between where the traps are placed, the type of bait that's used, and the specific individuals that set these traps can all bias capture success. Now, the species also appears to be trap shy, meaning that once it's captured, it's unlikely to be recaptured again, which is an essential component of capture-recapture studies. However, in recent years, passive acoustic telemetry has emerged as a powerful tool to monitor populations. And so with acoustic telemetry, researchers will attach transmitters to individuals, which then communicate to these acoustic receivers that are deployed underwater. And so these transmitters are able to communicate to these receivers through sounds at specific frequencies. Now, acoustic telemetry has become an effective method at collecting robust long-term data sets with minimal effort once these devices are deployed, and also requires minimal disturbance to these individuals as well. However, passive acoustic telemetry has rarely been used to survey for freshwater turtles and has yet to be used to survey for alligator snapping turtles. And so the goal of this project was to quantify the impacts of passive fishing gear on the demographic parameters of alligator snapping turtles. And so the first objective was to estimate various population parameters, including detectability, survival, and density of the species. And then our second objective was to assess the use of passive acoustic telemetry for monitoring alligator snapping turtle populations. So in addition to those other two sites that I mentioned earlier in this talk, we also surveyed Alzan Bayou Wildlife Management Area, which was unfished and is located on the southern border of Nacogdoches County. And so now we've kind of set up this fishing pressure gradient here, where Alzan served as our unfished site. The Atoyac off to the right served as our low passive fishing gear density site, and Shawnee in the middle served as our high passive fishing gear density site. And so again, all three sites are fairly small streams with an abundance of woody debris and high canopy cover. They also all lie within the Neches River Basin and the Piney Woods ecoregion, right in the heart of the species range here in Texas. And so we then surveyed for alligator snapping turtles from June 2023 through August of 2024. And we divided these surveys into two parts. So we had our summer surveys in 2023 and 2024, which were weekly surveys. So this required us to go out in the field about 6 days a week through the entire summer. And then during the school year, we surveyed from August 2023 through May of 2024, and these were monthly surveys. So go checking these sites once a month. Now, during our surveys, we deploy 15 baited hoop nets overnight, spaced approximately 100 meters apart. And we primarily use carp for our bait. And so I would attend these bow fishing tournaments, collect as much free bait as I could, and then we chop it up. place it inside these bait canisters, which were constructed from PVC with holes drilled into the side, which basically allowed for continuous scent dispersal once one or more individuals entered the traps. Now, once individuals were captured, we aged, sexed, weighed, and collected both straight and curved morphometric measurements. And then before we released these turtles, we marked them all on their marginal scutes for future identification. Now, we also quantified the habitat conditions around the traps as well, which included data such as water depth, water temperature, canopy cover, flow, presence of submerged woody debris, and much more. I then compared these differences in habitat structure among our sites with a pairwise Permanova, and then visualized these differences with an NMDS. And so from this analysis, Alzan, our unfished site, was the only site that differed in habitat composition, which had slightly narrow channels, shallower depths, and higher canopy cover. And so this NMDS shows this, where Alzan is that so each of those polygons on the NMDS represents a site. And so the polygon on the bottom is Alzan Bayou, our unfished site. And as you can see, it does not overlap with the other two sites, and just kind of highlights how dissimilar the habitat composition is there. However, our two fish sites, the Atoic and Shawnee, are up top. And as you can see, there's quite a bit of overlap with these polygons, which shows how similar the habitat composition is at those sites. Now, before we released all of our turtles, we also attached acoustic transmitters to 9 individuals at each site, except for Shawnee, in which we're only able to tag 7. And then in conjunction with the transmitters, we deployed 6 acoustic receivers across our sites as well. And so this image here is Alzan Bayou, and these orange triangles represent our receiver locations, where we try to place these receivers near possible entry or exit points across our sites. And the furthest 2 receivers stretched out approximately 4 to 4.5 kilometers of stream, and the ones on each end served as gates. And so from these gates, we are able to determine whether these individuals were leaving or entering our study area, which improved our population estimates. And then the data was downloaded from these receivers approximately every 6 months. And so here's kind of a crude illustration I made up showing how we deployed these passive acoustic receivers. And so as you can see, we had this passive acoustic receiver, which was stuffed inside an orange styrofoam buoy. This receiver was attached to a smaller river anchor. And then from that river anchor, there was 2 chains. And so one chain was attached to a much larger, heavier pizza anchor. And then the other chain was connected to a tree overhanging the bank. All right. And so this figure shows the number of individuals captured from our hoop nets over the course of the study. And so as you can see, we weren't very successful at capturing alligator snapping turtles from our hoop nets. In total, we had 56 captures across 915 trap nights, with a total of 4 recaptures. All 4 took place at Alzan, our unfished site, and 3 of the 4 came from the same individual. So again, we weren't very successful at detecting individuals with these hoop nets. However, keep your eye on the y-axis here. And when we compare this figure to our acoustic receiver data, you can see that our acoustic telemetry was much more successful at detecting individuals, in which they're able to record nearly 800,000 detections of the 25 turtles that we tagged over the course of the study. Now, we then calculated the catch per unit effort by dividing the total number of individuals captured by the total number of net nights. We then tested the differences in age structure and adult sex ratios with chi-square tests and Fisher's exact tests due to the low number of captures. And so this figure shows the catch per unit effort of alligator snapping turtles across our study sites. So on the x-axis are the sites, and the y-axis is the catch per unit effort. And so overall, catch per unit effort declined with increasing passive fishing gear density. And so we had the highest catch per unit effort at Alzan, our unfished site, at 0.08, followed by the Atoic, our low passive fishing gear density site, at 0.07, and then lastly, Shawnee, our high passive fishing gear density site, at 0.03. This next figure shows the age structure of the individuals that we captured over the course of the study. And so on the x-axis are the sites, The y-axis is the number of individuals. So overall, we found no significant difference in age structure among our sites, likely due to the low number of captures we had. And so at Alexander Unfished site, we captured slightly more adults than juveniles. At the Atoic, our low passive fishing gear density site, we captured a near equal ratio of adults to juveniles. And then lastly, at Shawnee, we captured more juveniles than adults. And then this next figure shows the adult sex ratios of those individuals that we captured. So again, on the x-axis are the sites, and the y-axis is the number of individuals. So overall, we found no significant difference in adult sex ratios as well, likely again due to the low number of captures. And so at Alexander Unfished site, we captured slightly more adult females than adult males. At the Atoic, our low passive fishing gear density site, we captured more adult males than adult females. And then lastly, at Shawnee, our high passive fishing gear density site, we only captured 3 adults. So we captured 2 adult females and 1 adult male. Now, to estimate the population densities of alligator snapping turtles across our sites, we used a spatial capture-recapture Jolly-Sieber model. So in typical capture-recapture models, population estimates can be biased for not accounting for the variation in capture probability. And this bias stems from the distance between the animal's activity centers and the survey locations. And so this figure kind of highlights this. So where the distance from the animal's activity center increases, the probability of detection will decline. However, spatial capture-recapture models differ from typical capture-recapture models since they account for both the spatial location of the sampling device and the individuals. And so the models we used were open population models, which allowed us to estimate abundance, survival, recruitment, detection, and movement. Now, due to the large number of detections we had from our acoustic receivers, we reduced the detection histories into monthly time steps. We then determined whether these individuals were alive or dead at these times, or whether the individuals were within or outside the study area at these times. And since I continued to trap for alligator snapping turtles long after attaching the transmitters, to improve our population estimates, we included these unmarked individuals into our models as well. All right, so these two figures represent the baseline detectability and the density of alligator snapping turtles at our sites. So starting up at the top in figure A here, so on the x-axis are the study sites, and the y-axis is the detection probability. So overall, detection probability decreased with increasing passive fishing pressure. So we had the highest detection probability at Alexander Unfished site, and the lowest detection probability at Shawnee, our high passive fishing gear density site. And then moving on to the bottom there, shows the density of turtles per kilometer of stream. And so at Alexander Unfished site, we estimated a mean density of about 15 individuals per kilometer of stream. However, at the Atoic, our low passive fishing gear density site, we estimated about 15 and a half to 16 individuals per kilometer. However, as you can see, there's quite a bit of overlap with these estimates. Therefore, there's no significant difference between these two sites. However, at Shawnee, our high passive fishing gear density site, we estimated the lowest densities of alligator snapping turtles at about 8 individuals per kilometer, or about half of what was estimated at the other two sites. Now, to evaluate the effects of environmental and individual level covariates on detection and survival, we employed a multi-step modeling approach. And so we first developed a series of 2 sets of preliminary models. The first set included environmental covariates, which included water depth, water temperature, flow rate, canopy cover, monthly precipitation, and passive fishing gear density. The other set of preliminary models were individual specific covariates, which included age class, adult sex, and mass. We then selected these significant covariates and developed a final set of 5 models, each testing these different parameter combinations. And so these last 2 figures I'm about to show were from our best fitting model. And so the best predictor of detection was sex. And so this figure shows this. So on the x-axis is sex, and the y-axis is the detection probability. And so overall, females alligator snapping turtles were nearly twice as likely to be detected than males. And then this last figure shows the survival probability of alligator snapping turtles with increasing passive fishing gear density. And so on the x-axis is passive fishing gear density, or passive fishing gear per kilometer of stream. And then on the y-axis is the survival probabilities. And so overall, survival decreased with increasing passive fishing gear densities. And then I also included this vertical red line here just to highlight the highest passive fishing gear density estimate we had during our study at Shawnee in the fall of 2023. Now, as you can see, there's quite large credible intervals here, that gray shading. Again, this is likely due to the low number of sites that we surveyed. We only surveyed 3 study sites. And so expanding the geographic extent of the study, could narrow these confidence intervals. And so, as I mentioned earlier, there's many issues when it comes to surveying for alligator snapping turtles with hoop nets, and the drastic changes in water conditions from the severe drought and the flooding issues at all 3 sites inhibited our ability to deploy traps, and also likely deterred turtles from entering our traps. However, these acoustic receivers were highly effective at detecting the tag turtles through the variety of environmental conditions that we experienced. And I mean, this is further emphasized here with our nearly 800,000 detections from our acoustic receivers versus the total of 4 recaptures we had from our hoop nets. And while the baseline detectability was much lower in this study compared to other studies, it's kind of difficult to compare these estimates. And so during our study, we employed a continuous monitoring approach during the winter when the species isn't very active, while most other studies conduct surveys less frequently and during periods when the species is most active, which will increase the probability of detecting individuals. Now, we also saw detection probability vary by sex, which was likely due to the sexual differences in movement patterns in the species. And so although the literature isn't very clear on this, it does seem that females may have smaller home ranges than males. And so if these home ranges are overlapped with these acoustic receiver ranges, this may explain this increase in detectability. And also, male turtles are known to move great distances in search of mates and to avoid male-on-male competition. So it's possible they may be more inclined to leave the study area. Now, we also know from previous studies that the relative abundance of alligator snapping turtles varies geographically, and that the species prefers habitats with an abundance of submerged woody debris and canopy cover. And so we were able to account for this by choosing sites that were relatively close to ensure that these large-scale geographic factors had minimal impacts. And when it comes to habitat structure, Alzan, our unfished site, was the only site that differed, while our 2 fish sites were similar in both their physical and environmental characteristics. Therefore, the main difference between our 2 fish sites was passive fishing gear density, which suggests that fishing pressure is likely driving these dissimilarities in population structure, not habitat. Now, the density estimates of alligator snapping turtles were also the lowest at the site with the highest densities of passive fishing gear, and we found that survival probability of alligator snapping turtles declined with increasing passive fishing gear densities. Now, this makes sense since due to those life history traits that I mentioned earlier, their delayed sexual maturity and their low fecundity, just a slight increase in adult mortality, especially adult female mortality, can lead to population declines. Furthermore, due to its large size, its opportunistic scavenging behaviors, and its propensity to travel long distances, alligator snapping turtles may be more susceptible to entanglement from passive fishing gear than other freshwater turtle species. And as it mentioned earlier, the majority of passive fishing gear found during this study was abandoned, which just highlights the impacts that these abandoned devices have on the species. We also estimated the highest densities of alligator snapping turtles in the entire state. This also makes sense since we surveyed within the core of the species range here in the Neches River Basin, while Rosenbaum et al. 2023 surveys were range-wide and included sites where the species wasn't found. And to kind of further emphasize this point, this figure is from Rosenbaum et al. 2023, and that darker shaded region represented the Neches River Basin with the highest catch per unit effort of alligator snapping turtles. And so what we think may be at play here is a case of source sink dynamics, where since we were surveying within the core of its range, there's plenty of these population sources for these sites that are subjected to passive fishing pressure to pull from. However, as we leave the core of its range and out into the periphery, we could expect that the impacts that passive fishing gear has on alligator snapping turtles to be more harmful, since there's less of these population sources to pull from. So therefore, these populations on the edge of the species range may be something important to monitor in the future. Now, it's also unclear whether passive fishing gear is an additive or compensatory mortality source. And so compensatory mortality means that the mortality from passive fishing gear would simply replace the natural deaths, resulting in no change in total mortality. While additive mortality would add on to total mortality, resulting in population declines. So based off our results, it appears that at low passive fishing gear densities, like at the Atoyac, these devices may be compensatory, which would explain why we found no significant difference in turtle density between the Atoyac and Alzan. However, at high gear densities, like at Shawnee, passive fishing gear may be an additive mortality source, which would explain the lower densities of alligator snapping turtles at that site. And it also may depend on the age of the individuals that are caught as well, since adults are long-lived and have high survival rates, often exceeding 90%. It may be additive to this age class, while juveniles have high mortality rates due to predation and other factors, so fishing pressure could be compensatory. So I know this was a lot of information, and to wrap up this talk, there's a few management implications I want y'all to take away from this study. First, these acoustic receivers appeared to be an effective method for detecting alligator snapping turtles, and in conjunction with hoop nets, it may standardize how we monitor these populations in the future. Furthermore, to reduce the impacts that passive fishing gear has on alligator snapping turtles and other aquatic vertebrates, organized river cleanups may be necessary to remove abandoned gear. And so during periods of low gauge height and river discharge, we could further optimize these cleanups when the detectability of passive fishing gear is improved. And when it comes to addressing the issue of abandoned fishing gear, we already have regulations in Texas when it comes to this issue. It's just a matter of enforcing these rules. And so addressing this persistent threat is critical to maintain stable alligator snapping turtle populations and to ensure the long-term viability of the species across its range. And with that, I want to thank the funding partners, Texas Parks and Wildlife Department, U.S. Fish and Wildlife Service, and the USDA McIntyre Stennis Program. I also want to thank Paul Crump for hosting this webinar and kickstarting this project, and Bob Baker, who allowed us to survey at Alzan Bayou. And then lastly, I want to thank all of our technicians and volunteers for their fieldwork assistance. As I'm sure many of y'all can imagine, surveying for alligator snapping turtles is not an easy task, and they all did a great job. And so with that, thank you all for attending this webinar. If you have any questions, let me know or reach out to my email down below. Thank you.
Hey, Luke, I made it back. Sorry about that rather embarrassing epic fail there at the beginning. Please, there are a couple of questions in the chat and we'll read them out here in a second, but if you have any more, please go ahead and put them into the Q&A section here. Yeah, and just I'll mention that I added Chris as a co-host here in case whatever happened earlier happens again. Chris will be able to read the questions out. Okay, so great presentation, Luke. Thank you so much. That was really great. So the first couple of questions in here, did you remove any of the abandoned gear when you came across it?
We did not. So the purpose of the project was to examine the persistence of the gear, and so we didn't want to start removing it during the study.
Okay, are there any regulatory actions that you think may actually be effective at deterring illegal passive fishing? You may have already touched on this a little bit.
Yeah, so I mean, I'm just a researcher, so I don't want to get too specific into, policy or anything like that. But I think the biggest issue is that we do have regulations. So each trot line, limline, jug line, they're supposed to have a gear tag with the angler's name, number, address, contact information. And these devices are only supposed to be deployed for at most 6 days. And so I think just enforcing these rules would solve most of these problems.
It strikes me that there's a lot of ground to cover for game wardens.
Yes.
Yeah,
Yeah,
it's pretty
that's
hard to stay on
definitely the
top of
big
all that.
issue.
Okay, there's a comment about registration. I'll deal with that afterwards. How often did you encounter fishers, and what was their reactions to you? What were their reactions to you?
So we encountered them, let's see, almost every time we went out in the field at Tiatoic and Shawnee, there was either a boat or someone fishing off the bank. Everybody was very cordial. I didn't get too specific into this project, mostly because of the status of the species, and poaching is a major issue for alligator snapping turtles. And so I didn't want to discuss the exact species that we were surveying. So the extent of what I told them was we were surveying for freshwater turtles. But I never had a negative interaction with any angler.
Okay, great. Did you have any recaptures from the Rosenbaum et al. 2023 study?
I did. So I can't remember off the top of my head. We probably recaptured about 5 individuals from Rosenbaum's. Connor Adams, who used to work at Stephen F. Austin, also surveyed out there. We captured some of his individuals that he tagged or marked as well.
Is that across all the sites or just at one?
Just at Alzing. We never captured any individuals with markings at the Etoic or Shawnee.
Okay, is there a pattern in the type of tackle used to give us information on if there is a way to modify them to make them less attractive to non-target species? I see.
Yeah, that's a good question. You know, I don't think so. I'm sure there could be different styles of hooks that are less likely to maybe snag an individual, because often when I discuss this project, most people think they're biting onto these hooks. And from, incidental reports, it seems like it's almost 50-50 of getting snagged versus biting onto the hooks. So I'm not sure. I think the biggest thing is just to be checking your lines frequently.
Very good. Will the presentation and slide deck be archived for future viewing? Yes, we'll have it. It was almost all of it was recorded, so we'll have it up on the YouTube channel at some point soon. We could send a link out to that, and you can find it on our website. Okay, the questions are coming in hot now. Did your research devices experience any vandalism, and if so, how did you handle it?
They did. So originally we deployed 6 receivers at Alzane, and we deployed 7 at the Etoic and Shawnee. Early on to the first summer of our surveys, one was stolen at Shawnee. With the drought, the receivers got more exposed, especially people boating down the river and seeing these massive chains hanging from trees into the water. I think it kind of enticed a lot of people to check out what it was. And so that one was stolen. Let me think. The one in the Toyuk, I believe, went missing. And so, like I said, we wrapped them around trees, and a lot of these trees fell into the river as a result of the flooding in the summer of 2024. So I believe that tree just simply fell into the river, and we lost that receiver. And then towards the end of my field work in August of 2024, one receiver was pulled up all the way up onto the bank and just set there aside. And so we placed them inside these buoys. I did spray paint them green to maybe mask the significance of them. We also spray painted the chains brown just so they wouldn't give off such a glare. But beyond that, that's as much as we could really do. We were trying to conceal them as much as we could.
Okay, next question is, what are people poaching alligator snapping turtles for?
That's a good question. It depends on the person. So there's people that poach them for their meat. and it's mostly meat or the pet trade generally. And so I know there's been an issue in it's been discussed of people traveling from Louisiana coming across Texas and poaching turtles. I know there was that big incident a few years back, but in general, it's meat and the pet trade.
There's a kind of a comment question here. It says, as part of the fishing license program, how about a requirement that each licensee also does a certain number of hours of river cleanup? It's a interesting idea.
Yeah, yeah, that is interesting. I'm not sure how you could enforce it, but that'd definitely be nice to do.
So there's a comment here. It says, I know of a study that samples AST biannually, spring and fall, at the same sites. It would be interesting to learn how long the trap avoidance memory lasts. That's an interesting question and point about, maybe the repeated sampling keeps the trap avoidance fresher than if you're, sampling it regularly.
Yeah, I think that's the main issue that happened during this study. And so at least comparing this to Rosenbaum's study, who was also an SFA master's student. Like I said during the talk, it was range wide, which required, I believe it was 3 days of surveys across like over 50 sites. So the turtles are less, I could imagine they'd be less likely to be, I don't know what the right word would be, scared, versus surveying the same locations for almost 2 years straight. I could see they'd be less likely to be captured. And we kind of saw that with the data too. We had a lot of captures right off the bat, and then it just declined throughout the study.
Okay, how many dead alligator snapping turtles did you find on the lines?
We didn't encounter any. We didn't check the lines, so it's possible there could have been some that we boated by, but we didn't want to, disturb any of the anglers out there. So we just boated by, recorded the data, collected a GPS point, and boated off. We did find an abandoned hoop net during a survey with a dead soft shell in it. And there was an abandoned trot line that was about to get caught in our boat prop, so we had to cut it, and there was a live soft shell caught on that. So we released that turtle as well. So we did find some illegal devices. There was another illegal style perch trap that was full of, I believe it was river cooters that were stuck in there. So we rescued those as well. But specifically alligator snapping turtles, we didn't find any.
Okay, great. Another kind of comment and question. Thanks for this important work. I'm skeptical that making sure fish lines are legal, i.e. labeled, would reduce the number of ingested fishing gear. Can you help convince me?
Yeah, so I think, at least from my point of view, if these people tag their lines, they'll be more likely, they'll be more responsible for them, or feel more responsible for what they're putting out. So they'll be less likely to abandon the lines, and then therefore less likely for these turtles to ingest fish hooks. But yeah.
Yeah, I think the important thing would be getting as many of the illegally deployed or abandoned ones out of the war, right?
Mm-hmm.
Yeah,
Exactly.
another comment here. Really an excellent presentation. Seems like we need support for law enforcement personnel to be able to monitor for appropriate gear tag compliance and the number of days lines are deployed. Yes, I think that's a really good point.
Yes. Yeah, that's the big issue. Is like you said earlier, there's a lot of ground to cover, and these turtles like to live in, kind of fairly remote systems, which is difficult for these law enforcement personnel to access. So there's a lot of issues to tackle here.
Okay, another question. Was there any correlation between number of hooks on a line/device to population, or was each line, regardless of the number of hooks, considered one line or device? I think I understand that question.
So let's see if
How did you categorize the fishing gear? Was it like a
the fishing
line
gear.
or the number of hooks?
So we couldn't always determine the number of hooks because we didn't directly handle these lines. So most of it was based off the position. And so limb lines typically, like the name suggests, it's attached to a limb or a tree root, and it just hangs vertically from that structure. Meanwhile, trot lines are typically set fairly horizontally, either running along the sides of the banks or going from one bank to the other. So that's how we were able to determine. When it comes to the number across each site, so I believe Shawnee, our high passive fishing gear density site, had more trot lines, not significantly more, but it did have more than the Atoyac. And then it also had the lowest densities of alligator snapping turtles, but that's kind of correlative, I guess.
Yeah. So do you have any perspective on why the Shawnee site had higher passive fishing gear densities?
I think it's closer to Nacogdoches, the city. So I think that's a big part of it. So the Atoyac, the site where we surveyed, the closest town was Sherino, which isn't very populated. So the Atoyac is a bit more remote. I'm assuming that's why. Shawnee is kind of a popular hub around that area to fish at.
Okay, great. Somebody has a comment here. As Texas Master Naturalist, what can we do to help? Luke, let me take the opportunity just to talk a little bit about some of the stuff that we tried to do here at Parks and Wildlife. A few years ago, we took a run at the idea of a cleanup program, and it was initially supported based on the changing of the regulations. You know, basically anything that was illegally deployed or abandoned is classified as trash, and anybody can remove trash. We ran into a challenge though with determining whether any particular fishing gear was illegally deployed or abandoned, and so that inspection authority is only granted to law enforcement officers. So technically, nobody except a law enforcement officer, a game warden in reality, can determine if a trot line or a passive fishing gear is illegally deployed or abandoned. So we've kind of got this pinch point where we still require law enforcement to be able to help us, get it out. So a cleanup program may be possible, but there's some logistical challenges to actually implementing that at any scale that doesn't still involve an individual game warden inspecting every piece of gear to conclude that it can be removed from the water, which is a challenge.
Mm-hmm.
Okay. Was the high number of fishing line reducing prey fish? Oh yeah. Was that involved, do you think, in the sort of indirect cause of fewer turtles?
I can't say it has no effect. Looking at our bycatch data, we caught a lot of fish bycatch during the study. Um, it's kind of hard to tell. So Alizan, our unfished site, had the most fish. Meanwhile, I believe Shawnee, the high passive fishing gear density site, had the lowest amount of fish bycatch. But it's kind of hard to say. I mean, they are turtles, so they can go quite a bit of time without eating. So I wouldn't. It could be a factor, but I don't think it's the main factor, I would say.
Yeah, very good. Okay, comment here, great talk. This would be a great opportunity for a community education outreach initiative, maybe some signage at boat launches, events, etc.
Yeah, it would be. So I believe, and maybe Paul, you can talk about it. There are some signs posted just about what to do if you encounter ASTs and how to report them. But there's nothing really talked about much about trot lines or other passive fishing gear being deployed.
Yeah, you're right. I think this would be a really good opportunity to, if there's nothing kind of that we can do regulatorily, maybe there's some, maybe there's some community buy-in we can get for this stuff. And on a related question, next one is, as an avid fisherman who finds many abandoned trot lines, what is your recommendation as to what to do with these? Report, remove, or leave them alone? I would say report them. I think it's Sounds to me like this is going to be a law enforcement issue. I wouldn't recommend, messing with somebody else's line. Maybe if it's really clearly out of war or something, like you could justify removing it, but it'd probably be better to report it to the game wardens, which we might then get a more accurate sense of the scale of it, if more of that's reported as well. What do you think, Link?
Yeah, I agree. I think as long as it's not presenting a danger to you, because a lot of times these abandoned trot lines, especially when the water drops, it can be a big hazard for boats getting caught in your props. We've had a couple trot lines get stuck in our boat prop. So yeah, as long as it's not a major hazard, I think reporting it's the best option.
There's another really good question here. It says, it sounds like an abandoned fishing line season similar to abandoned crab traps would be useful. Kind of a closure, right? Where anything during this particular period of time is illegally deployed, allows us to easily identify what's abandoned and junk over what's legally deployed. It's a very interesting idea, and I believe that was talked about at some point in the past, but wasn't feasible.
Yeah, that is a good. I never even thought about that. That is a good idea.
Okay, I think we'll have to take one more. We'll do one more question, then we'll have to wrap it up. Did you see any age structuring, or was any one age group more susceptible to capture?
So like I said, we didn't directly observe any captures, but from the anecdotal reports of alligator snapping turtles getting caught on trot lines, it seems like it affects both age groups. You'll see pictures of both small ones and large ones. You'll probably see larger ones posted more often. That's probably just because of social media, and you'd rather share a picture of you with a larger turtle than a smaller one. But I think it affects all age groups. Now, the impacts that it has on the populations is, I would say, different. So, like I said during the talk, these large breeding adults, are very important to maintain stable populations. And so just losing a handful of these large adults, especially these large adult females, that can crash a population versus losing a few juveniles or so.
Yeah, okay. Luke, really appreciate your time. This is a great talk. Lots of good questions.